Hello, this is Gary Parker. We're going to take a look at functions today, domain and range briefly. So let's consider a function or the equation y equals x squared. So my claim is that it's a function. So remember what it means to be a function, that for any input, any x value we plug in, there's no more than one output. So let's just pick a couple numbers and see. So I'm going to make a table for x and y. So if I pick x to be 2, for example, then y is going to be 2 squared. Now remember, whenever we substitute in, we should put it in parentheses to be safe. Well, 2 times 2 is 4. And so I think we'll all agree that 4 is the only possible answer. I could pick x equals 0, and then I'll get 0 squared, which is 0. And maybe I'll try negative 2. That's negative 2 times negative 2, which is 4. All right, so I believe this is a function because for any x value I plug in, I get no more than one answer. So that means I could rewrite this in function notation and say this is f of x equals x squared. Just noting that it's a function. What does f of x mean? Well, f of x means it's a y value. Comes from using this formula on that side. Other things that the function notation is useful for is making statements like f of 3. Now remember, the translation of that is that x equals 3, y equals what? And so we can plug into our formula. In this case, f, our function, the rule is take the number and square it, so it's 9. So we just calculated that f of 3 equals 9. So that's a lot like writing a point. So on the graph, we'll have the point 3, 9. On the other hand, if I wrote something like f of x equals 16, in this case, remember f of x, that notation, that means it's a y value. So the interpretation here, the translation, is that y equals 16, backtrack and figure out what x could be. And that's always a harder problem. That's a question mark, by the way. Yeah, that's always a harder problem. That means I have to solve the equation x squared equals 16. All right, so I'm not going to solve that right now. I'm just making a note of the different ways I can use the notation. I want to look at this graphically because I want to figure out what's the domain and what's the range. And I mentioned those in the introductory video. Domain are all possible x values that you're allowed to plug in. The range, those are all possible y values you end up with. And usually you can look at the equation and figure out the domain. So for example, I can square any number I want. So in this case, the domain should be any real number. The range, usually you have to look at the graph to figure that out. So I'm going to whip out Desmos. So some of the videos show a TI calculator. I don't recommend using a TI calculator. They're clunky. There we go. So I'm going to search for Desmos here. I have links to it earlier in the course. And I'm going to use their graphing calculator. And you can use this on most tests. All right, so I'm going to enter it as a function. So I'm going to say f of x equals x squared. To get the square, there's a couple of ways you can do that. On the keyboard, if you hit Shift-6, that's the caret key or caret. Shift-6, there we go. And that raises up into the power position, so I can put the square there. If I need to type something else after that, maybe I want to arrow to the right to get out of that superscript position. Another way you can get a square is from the keyboard. type your x, and then hit the a squared button. Sorry, the screen keyboard. Okay. And yet another way to get the power in Desmos is the a to the b. So if you want something other than a square, this just raises you into the power position, so you can type any number you want, cube power or fifth power or seventh power or tenths. We want the second power. All right, so I just want to look at this graph and try and figure out what the domain and range is by just looking at it. So let's get a screenshot of that sucker. And that should be enough right there. Window here. All right, so playing around with this graph. So domain are the x values. So looking at the graph, any point on the graph has an x value associated with it. And another thing to consider about this graph is, since I can plug in any x value I want, it continues going up and to the right forever. And I can plug any number, any negative number I want, so it's going to continue a pattern of going up and to the left forever. So it's usually a good idea to draw arrows on a graph to indicate it continues a pattern or not. In this case, it continues on both sides. It doesn't dead end. And given that, if I shined a flashlight down from the top of this graph, wherever the top happens to be, it would form a shadow everywhere on the x-axis. So that tells me, in this case, that the domain, remember all the x values I get to plug in, is definitely all real numbers. Now let's look at the range. The range are the set of all possible y values. So any point I pick on the graph has a y value that goes with it. No matter which point it is, it's going to have a y value to go with it. Now notice the smallest y value we see is right here at the bottom of this graph. There are no y values underneath 0. That's because we're squaring a number in this case, so that kind of makes sense. If I square a positive, the answer is positive. If I square a negative, the answer is negative. So looking at the y-axis here related to this graph, it would seem that the range, the y values, are only y values that are greater than or equal to 0. Okay? You're going to use something called interval notation to tell the computer how to what your answer is. So interval notation. So in this case, the interval notation, if you consider the number line here, I would start shading at 0 for the range, and then I would shade every number above that. And so whenever you make interval notation, you have to state the numbers in numerical order. So 0 is the smallest number in the interval, comma. Since it goes up forever, there is no highest number, so we put the infinity symbol, which is that crazy symbol right there. Since 0 is part of, right, so I have that greater than or equal to, I put a square bracket because of the or equal to. Infinity isn't a number, I can't plug it in, so I put a parenthesis to indicate just head in that direction. So that's the interval notation. That means the same thing as y is greater than or equal to 0. For all real numbers, in that case, we can go to the left forever, we can go to the right forever. The interval notation for all real numbers would be a parenthesis, negative infinity, comma, positive infinity, go to the right forever. Let's look at one more example for domain and range. And so I'm just going to delete this function for now. Now, often we use f to indicate a function, but we can use any letter we want. So I could call a function g of x instead of f of x. It's just a different name for it, like Gary versus Bob. So I'm going to use the square root function. So it's the opposite of squaring something. And so one way to get that is with the symbol here at the bottom of the screen on the GeoGebra keyboard. And if you have the app on your phone, it's there too. Oh, I forgot to type equals. Equals. And then I hit square root, and then I type x. So it's showing me the square root of x here. Okay. Another way to get that, and I could call it y equals if I want. I just prefer function notation because this is chapter 2 on functions. The kind of international abbreviation for square root on a computer is SQRT. And once I finish typing that, Desmos, sorry, different program, Desmos says, hey, there's the square root. That's what you want. And for example, I don't know if you know, Google has a calculator. If you go to a search bar and you type 2 plus 2, Google responds by giving you a calculator. And then 2 plus 2 is 4. And then I could say, hey, what's the square root of 4? Close the parentheses, equals, and it says 2. Similarly, I can engage the calculator. Let's close this and start over by typing the abbreviation for square root, right, which is SQRT, parentheses, and then I could put, say, a 16 in there, or let's go 25, close parentheses, enter, and the Google calculator immediately says, oh yeah, square root, that's the same thing as this symbol down here, and the square root of 25 is 5. So it's a good thing to know. You'll end up using this a lot in a future chapter in the book. So let's close that one, and we just need to focus on this one. So I just want to look at this graph and try and identify what the domain and range is. So new page, screenshot, and let's take a look. So as far as, let's just think about the square root function for a moment. So this is the function. I'm calling it g of x. Equals the square root of x. And I usually put a little hook on the end indicating what's inside the root and what's not. And I'll talk more about that in the chapter on square roots in the future. So thinking about numbers that I could plug in for x and spitting out a y value, the g of x, I can plug in 0 because the square root of 0 is 0. Because 0 times 0 is 0. I could plug in 1. Square root of 1 is 1. I could plug in 2, and the square root of 2, I'd have to ask my calculator for that. And funny thing about square roots is some of them are crazy numbers. They kind of go on forever. So SQRT of 2, and Google says it's 1.414213562337, and it actually goes on forever and ever and ever without repeating a pattern, which is kind of nuts. So I'm going to call it about 1.4 in my notes here. Oops. So that's approximately wavy equal sign to indicate I rounded 1.4. Things I can't take the square root of at this point in time. If I tried to take the square root of -1, most calculators will respond with an error. And the error message depends on the calculator. We'll talk more about that later. So, and the reason for that is, remember, what does the square root mean? Square root of some number a is equal to some other number b if b squared is equal to a, right? Check, square root of 9 equals 3. 3 is my b. Why? Because 3 squared is 9. And if I square, the problem with that is when I square a negative number, I get a positive number back, which is trouble because I have a negative inside. So the question is, if I take the square root of -1 and I say that's equal to question mark, that means question mark squared has to be -1. The problem is when you square a negative number, you get a positive, and when you square a positive, you get a positive. You don't get a negative. So what does this mean? That will come up in a future chapter. It actually does mean something, but it's weird. Anyway, you'll notice that there are no points on this function related to negative numbers, right? If you pick like -1 over here somewhere and you trace up, you never hit the graph. If you trace down, you never hit the graph. So this function right here, let's use red to highlight the x-axis, only has x values starting at 0 and going to the right forever. So the domain here, you could say in inequality notation that x has to be greater than or equal to 0. In interval notation, you would put a square bracket because 0 is a legitimate number you can use, and then go to the right forever. As far as the domain goes, you have that point 0, 0, so the range starts here. And then my claim is that this function keeps going. As x gets bigger, the square roots gets bigger. And so this function continues to move right and climb forever. Okay? It gets shallower as you go out, but it still goes up. The square root of 10,000 is bigger than the square root of 1,000, for example. All right, so my claim then is that the range of this function, all possible y values I get from this equation up here, y has to be greater than or equal to 0. Pretty similar to the domain. Doesn't always work out that way. If I needed to state that in interval notation, I would state that the smallest number in the range is 0, and there is no biggest number. It goes up forever, parenthesis by infinity, because it's not a number I can plug in. But I can plug in 0 and get 0 back, so it gets a square bracket. All right, I think that's enough for now. Have a good day. Do good math. I'll catch you in the future.